Good afternoon. Many of you probably already know DARPA. We're most famous for having created the first internet. But for the past 50 years, we've been driving nation-scale research in artificial intelligence. And it gives us a kind of perspective on the sort of stuff that's going on today. And I thought I'd share that with you, because many of you are getting into artificial intelligence in large ways, and it's worth having that kind of perspective. Artificial intelligence started out, first of all, by people crafting the knowledge by hand. TurboTax is a great example of this. You have experts who are describing the information that they have, that they know. In this case, it's tax accountants and lawyers. And they build rules, and those rules get built into the application. And that application then is very effective in turning your financial information into the tax forms that you so love to submit. So handcrafted knowledge, the strength of handcrafted knowledge is that it's really good at reasoning about the behavior that it needs. So for example, TurboTax is better than I am at being able to figure out which tax forms to fill out. But in other dimensions of intelligence, it's far worse. So for example, it has only a rudimentary ability to perceive. It can figure out my W-2, and that's about it. But it has no ability to learn. If there's new tax law, then somebody has to sit down and create new rules. And it's certainly got no ability to abstract, that is, to take information that it knows and jump it up a level and do something interesting with it. But don't think that first-wave technology is old hat because of that. Just this summer in Las Vegas, we ran a cyber competition where 7 machines spent 10 hours attacking and defending themselves in the cyber domain against one another. And these machines went from discovering vulnerabilities to figuring out how to patch their own vulnerabilities, to figuring out how to exploit the vulnerabilities in other machines, to figuring out then how to repair themselves as a result of that. That whole cycle from bug discovery to fully patched was like a 20-minute cycle. So really hot, really new technology. But first-wave technology, this handcrafted knowledge, stumbles when it hits the real world. Back in 2004, we were pioneering some of the first self-driving cars. We were running them out in the California and Nevada desert. And that first year, in 2004, when we did it, no car completed it. In fact, no car got further than 8 miles on this course. And the problem was they couldn't tell what to do with things like shadows. Is it a rock, or is it actually a shadow? The next year, 5 cars completed it. What made the difference? Machine learning. It was a huge transformation. And that led us, or leads us to characterize a new kind of AI that we're in the midst of, that we can describe as statistical learning. And you're familiar with it from things like Siri, which, by the way, we pioneered also, face recognition, many other kinds of technology that is here in statistical learning. So in statistical learning, it isn't just the case that machines figure something out and start learning. Engineers spend a lot of time and effort building statistical models that they can then stream data into, and on the basis of those models, can train it to be able to be really good at figuring out how to respond in certain situations. And one major success this year was AlphaGo, where the most subtle board games that human beings had ever created, the computer was finally able to beat the best in the world. And it was powerful. But don't give up on human beings just yet, because this current wave of technology, though it's incredibly powerful, has fundamental limitations. And I'd like to take a little bit of time to convey that to you. But first, this notion of this statistical learning, what we've figured out now is that it's really good at perceiving what's going on in certain situations, and partly because it's really good at learning what works in one situation and what works in another situation. But notably, in contrast with first wave, the second wave of AI, this machine learning, as we call it, or statistical learning, is really poor at reasoning. And it's not able to do even the same kind of reasoning that TurboTax, for example, is able to do. And it's also poor at abstracting. What I'd like to do is open things up a little bit and give you a bit of an explanation as to why. Going to become just a little bit technical for a moment, and we're going to dive into some advanced geometry. There's a hypothesis which pulls on advanced geometry that says natural data, while it lives in data sets that have lots and lots of dimensions, they might be all the individual pixels, or they might be the digitized signals, or they might be different human attributes, this very large dimensional data space, the things that you care about actually clump together and form structures within it. I've got a visualization of this. Here's some data that I'm representing in 3 dimensions. And the original data has formed these individual clumps. So those blue clumps or the yellow clumps are examples of many versions of the same kind of thing. And you can see that they have a structure of like single lines, or that pink thing is like an orange peel that's curled in on itself. And the way that the statistical systems work is that they tease these apart by stretching and squashing the data space. So if I just work in 2 dimensions to make it easier to visualize, here I'm stretching and squashing the data space, and those original manifolds, those original clumps, which were the spirals, are getting pulled apart by those transformations, a squashing and a stretching, until you can very cleanly separate them. And this is what neural nets do. Neural nets do exactly this kind of stretching and squashing. Now, neural nets sounds very sort of esoteric, but here's the secret to neural nets. They're just Excel spreadsheets on steroids. That's all they are. So every layer just computes some computation based on the layer before until you get to the end and the answer comes out at the end. And each of these layers is squashing and stretching that data space, being able to separate things. Now, the remarkable thing about the particular form of Excel spreadsheets is that you start out with a sort of random structure, and based on the data, you learn what those weights should be. But at the end of the day, it's just that calculation. And that's part of the problem. We get great powerful things, including an autonomous ship that we have in sea trials just at the moment, but you also get failures like this. You get failures which no human being would ever make. So no human being would ever say that this is a young boy holding a baseball bat. Here's another example. The 2 pictures on the right-hand side and the left-hand side look identical to you and me. But to the visual recognizer, they look completely different. The one on the right is a gibbon. It's sure, 99% sure. And somebody knowing the algorithm that was being used could configure that little bit of image noise, add it to the image, and so confuse it. And many of you will remember the Tay bot out of Microsoft. This was the most polite version I could find to put up on the slide. The trouble was that this bot continued to learn as it interacted with human beings, and if you get human beings who lead it astray, lead it in a particular direction, put particular data to it, then it ends up being in a completely different place than you might hope. So these are challenges. And we see that these challenges need to have a fundamental next component of technology that we characterize as a 3rd wave of AI. And I'm going to give you 2 quick examples of contextual adaptation where you have a model inside. The first is to be able to make sense of what's going on in our neural nets. At the moment, when you get an answer, it comes out just, it's a cat because it's the highest value I came up with. But we would much prefer it to come up with an explanation as to why it came up with a cat. Another is we found that it's possible to have models that drive the decisions and actually allow you to train a system just with 1 or 2 examples, rather than the hundreds and thousands and even millions that you need today. And so in this particular case, it recognizes the digit by working from the end result back to the image itself. And so we're expecting some sort of pattern like this, where the machine builds its own contextual model, and we see that we'll get the ability to reason back in these systems. So I said there's 3 waves of AI. The first is handcrafted knowledge. Don't give up on it. It's going to continue to be critical. Statistical learning we're in the midst of, and stay tuned for what's going to be coming for contextual adaptation. Thank you very much.